I have this strange feeling that y'all weren't ready for this quiz. I don't know, maybe I'm wrong, but that shouldn't have taken 15 minutes for you to do that quiz. It should take you about 5 minutes tops if you understand the material, which is okay. I mean, it's not like you knew it was coming, all right? But I saw some of the work, and I saw a bunch of people doing the derivative of this using the limit definition, right? Limit, well, last week we learned the power rule, didn't we? Right? We learned the rule to take derivatives quickly. That should have been a really fast derivative. Let's go through it though, all right? So for this one, we're supposed to sketch the derivative, right? Here's the function. So it's straight line segments. That's like the easiest case because you can actually say exactly what the derivative is within each line segment. So like from here to here, I know that the derivative is just the slope of that line. So I just have to figure out the slope, right? So I pick this point here, go up 1, 2, 3, go over 1. I know the slope of that line is 3, which means when I graph the derivative, I just need to go up 3 and draw a straight line. So from here up to 3, open circle here, just like that, right? And then between here and here, it's the slope of that line, which I can get by doing, again, rise over run. So to get from here to here, I go down 1, 2, I go over 1, 2, 3, 4. So the slope of this line is negative 2 over 4, which is negative 1/2. So what I'm going to do, here's negative 1. Negative 1/2 is about right there. And I'm going to draw a horizontal line right through there, like this, just like that. And then from here on forever, what's the slope of this line? 0, so the derivative should be 0 all the time to the right here. So I'm just going to go like this. 0, right? So I'll stress this again. The y-coordinates of the derivative correspond with the slope of the tangent line on the original function, right? That's the connection. Are there any questions on this? All right, so that's that one. This one, what I wanted you to do is first find the derivative, right? And that should have been, like I said, that should have been pretty straightforward because we use the power rule, right? There's subtraction and addition. So I can do the derivative of each one of these separately, right? And according to last class, how do we take derivative of this now? What do we do? Bring the 3 out front. 3 times 3 is 9. 9x to what power? Second power, right? And then we have minus. Now same thing here. Bring the 2 out, hits here. We get 8. And then x, and we subtract 1 from that power, and we get 1. And then the derivative of a constant is 0. So there's your derivative. So you don't need to do a limit. You spend 15 minutes doing a limit. This should take you about, a minute at tops to do that. That's our derivative. Now, we're trying to find the equation of the tangent line, right? So first I'm going to find the slope of that line. To do that, I take the derivative, and what do I plug into it? The x value. I plug 1 into that, and when I plug in 1 here, I get 1. So now I have the slope of the tangent line, right? I need the equation. So all I need is a point, but I already gave you a point, right? There's the point. So you just go to the formula y minus y1 equals m times x minus x1, the formula we've been using since we started the class, right? And this is going to be y minus, let's see, y1 would be what? 0 equals the slope we just found, 1, and then x minus the x coordinate there, 1. So you just wind up, that's fine as an answer, but this is really just y equals x minus 1. That's it. Okay, so I'll grade these and get them back to you, hopefully this week. Any questions on anything else? Yeah, let's go ahead and just do that now. So I asked you to, if you wanted to, it was voluntary. If you wanted to do corrections on your test, you could turn them in, but the maximum you could get back would be 5 points, right? That was it? So If you have them for me, I will take them. I would like to see both so I can put them side by side and see what mistakes you made and then what. Do you mind? Here, pass that over. Oh. Anybody else? Oh, you got a lot. Okay, I'm sorry, I'm right over here. Got it? You don't need to staple them as long as they're together. Okay. Yeah, just like that's fine. Oh, wow, very nice. Okay, good. Anybody else? Okay, give me some time on these. These are going to be my back burner things to do, all right? So I will get them back and I will adjust your grades. Okay, y'all doing all right? That quiz seemed to have kind of changed the tone in here. Everyone seems a little depressed. Are y'all ready to get started? Today's a big day. Today's a very important day in this class. So y'all ready to roll? Yes, thank you. All right. So we are going to talk about the product rule and quotient rule today. Do y'all see the black towel around here? There it is, way in the back. So as of right now, if we want to find the derivative of something, we no longer have to use the limit, right? We have the shortcuts. But we are very limited still in terms of what we can find the derivative of. We need more rules. All right? So let me put up a problem as motivation first. So if f of x is x sine x, if I write that, before we even talk about derivatives, let's make sure we understand what this is, all right? When we write this, there's an implied multiplication. I'm okay. Was it offering help? Okay, now I just rewrote that just to stress some things to you. There's an implied multiplication right there. This is x times sine x, right? That's multiplication between these two functions. This by itself is a function. This by itself is a function. The operation, well, what's going on between this and this is not multiplication, right? The way we say this is sine of x. I'm going to write that down. We say that sine of x. In pre-cal, hopefully you were told that the thing that's inside this trig function is called the argument of the function. It's the thing that's being plugged into the function. So do not think that this is multiplication. It is not. Okay, it's telling you that you're going to evaluate the sine function at this value. So we only have one multiplication in this problem, right? You see it right there? There's only one thing, one multiplication symbol. There's two functions that are being multiplied. That is critical. It seems like subtle and like maybe duh to you, but it's very important that you understand that there's only two things being multiplied together here. So we want to know what's the derivative. And what we've learned up to this point is that if we have x to a power, right, we can take the derivative, right? We can use the power rule. We also know that if we have two functions that are being added or subtracted, right, and we want to take the derivative of this, then we can do that, just like we did on the quiz. We just do them separately, right? But we do not have a formula, or we do not have anything yet that tells us what to do if we have two functions, f and g, being multiplied and we want to take the derivative. Right now, that is an open question for us. We don't know what the answer is, right? We don't know. So I told you at the end of class last time, I gave you, it might have been this example, that it would be really nice if the rule was that you just take the derivative of each one, right? Wouldn't that be nice? If that were the case, just take derivative of x, take the derivative of sine, and you would be done, right? But that's not the way it is, all right? So I'm going to write the rule now for you, this very important rule. I'm going to write it over here, and then we're going to finish this problem. Actually, I didn't put what the instructions are here. Find f prime, all right? So we have the all-important product rule. This is in your notes. It's on your formula sheets. Product rule. I'm going to give myself a little more room. Okay, so here's what the product rule says. If you have some function f of x, and you multiply times g of x, and you want to know what the derivative is, here's what it is. What you do first is you take the derivative of this one, f. Okay, so you take the derivative of f, you figure out what it is, right? But then you don't multiply times the derivative of g, you just multiply times the g function without a derivative. That's the first thing you do. Then you add to this. Now you take the derivative of the g function and you multiply that times the f function, but you don't take the derivative. So it's like you're going to take turns. You're going to take this product, and the first thing you're going to do is take the derivative of the first one and then not touch the second one. And then you're going to add to that. Now you take the derivative of the second one, and then you multiply times the first one with no derivative. You see how you're going to take turns with the derivative here and add those two things together? That's the product rule. Now I'm not going to prove that to you. I think we voted as a class that I was only going to prove the power rule, and that the rest of them you would take on faith, right? That's what we agreed upon. So that is the rule. So I like to, the rule is great. You're going to learn it mechanically, but I'd like for you to try and learn it verbally as well, because it'll make your life much easier as we progress through the class. So instead of thinking about it like f and g, I want you to think about it as this is like the first function in the product, and this is your second function, right? Second function. So you have the first function times the second function, right? Another way you could look at the product rule verbally then would be that the derivative is equal to the derivative, I'm going to put DER for derivative, the derivative of the first times the second one plus the derivative of the second times the first. You're going to hear me say this a lot. I'm going to just verbally say that. Okay, hey, we have a product, right? So when we take the derivative, we're going to take the derivative of the first times the second plus the derivative of the second times the first. So derivative of the first function times the second plus the derivative of the second one times the first one. Understood? That's going to take a little time for you to get that down, but I think it's much more useful to learn it that way. All right, so you ready to do this problem? Let's do this. So if I want to come over here and I want to take derivative, let me erase this and just come back up here. Okay, so we have a product there, right? So we have to recognize we're trying to find the derivative of this. So what we see here is this split right here, right? That's our multiplication. And so if we look at our formula, we have to see that this is like the first function, that's the second one, right? So I would label, if I'm going to follow this would be the f function, right? And this would be the g. Now, there's already a problem that this whole thing was called f, right? But our formula requires f and g, so I have to call this f and g. So please understand that these two f's are kind of different. I'm just trying to get you to see the formula over there, right? That we have the two functions side by side being multiplied. All right, so let's follow it. What am I going to do first? Take the derivative of the first function, which is x, right? I'm going to write that down. I'm not actually going to take the derivative. I'm just going to write it down. I'm going to take the x, and I'm supposed to take its derivative, right? So I'm going to write prime. That means I need to take derivative of the first function. Now I multiply that times the second function, right, g of x, but I do not take the derivative, sine of x. Then I add to that. Now I need to take derivative of the second one, so I'm going to write sine x, and I'm going to take its derivative. I haven't done that yet. Times the first function x. Everyone see that written down? That clear? Next line, I actually take the derivatives. So what's derivative of x? 1. Okay, so that's 1 times, now this is sine x, we don't change it. And then plus, what's the derivative of sine x? Cosine x. You know that because we talked about that a class or two ago, right? And then times x. Okay? Now 1 times sine is just sine. And then over here, can you multiply these x's together and become x squared? No. This x is trapped inside this cosine, right? So that x, you cannot just push it next to this one. So what we do so that there's no confusion is we like to move this x out in front. So I put plus x cosine x. And that way everybody knows that these x's are not together, right? And that's it. That is your answer. That's a little more complicated than just taking the derivative of each one separately, right? Like it would have been really nice if that's what it was, but it's not. All right, you ready for another example? I'm going to use slightly different notation here. If y is equal to, let's go with this, t to the third plus t squared plus 1 times t to the fourth minus 3t minus 7. I want us to find dy dt. Okay. I'm using different notation here. So you can see here that y is this expression that depends on the variable t. So you can say y is a function of t here. And what I want to know is the derivative of y with respect to t. This notation, remember I showed you there's all these different notations for derivatives? This is just another way of saying, hey, go find the derivative of y, treating t like your variable. So let's do it. dy dt equals. All right, so the first thing that I have to realize is that I have a product here. Everyone see the product between two things? Right there. I have something being multiplied by something else, right? I could look at this as being the f function and this as being the g. And now you have to ask yourself, can I find the derivative of each one of those separately? Like, could you do it? If I had to take if I asked you for the derivative of that, could you do that? Yes, you feel okay? You could split these up, take derivative of each one, because there's addition, subtraction, and then power rule on those, right? So you could do the derivative of that by itself, and you could do the derivative of that by itself. So we should be able to do this, right? You following? Okay, so let me write the formula down. This is the f function. I want the derivative of that first, so I'm not going to take derivative yet. I'm just going to write it down, prime. Okay, times now the second function, t to the fourth minus 3t minus 7. Okay, we're halfway done with the product rule, writing it down. We've got this and this written down, right? Now I say plus, and I'm going to run out of room. So I'm going to erase the product rule. I'm going to write the product rule on the side over here so that we have it. So now the derivative of the second function times the first one. Okay, here's our product rule. I'll just put it here. Why don't you see if you can do the next step on your own? Just take the derivatives and stuff while I write this down. Dominic? Where's Dominic? All right, Dominic. You get to go first. 3t squared plus 2t. And the derivative of that was 0, right? Okay, should I put that in parentheses, Dominic? Yes. Okay, good. Everyone see that? Everyone agree? That's from last class. All right, and then I'm just going to rewrite this. And then Jordan's up. Jordan? No, Jordan? No, Jordan? Dazzler. You good?
Yes.
Okay, you get the next piece. Would it be?
4t.
It's gonna be, right? Come on, you confident in yourself. Yes?
4t minus
4t.
3.
So tell me what you did to get the 4.
Sorry, 4t.
Okay, 4t cubed minus 3. Perfect, yes? Everyone got that? And then just rewrite the next one. Now look, at this point, we are done with the calculus of this problem. Okay? The calculus part of the problem is over. The rest of that would just be algebra. We might need to multiply this stuff out. There's a lot of different algebra we could try with this to see, to clean it up, whatever. We're not going to do that right now. We're just going to say we've done the calculus, let's move on to the next problem. As this class proceeds, we will have to do something with this, and the algebra will come into play. So when you're doing your homework for this section, if you're checking your answers, you know how the ebook allows you to check answers? Your answer may not look like this because the book probably did some algebra to clean it up and do something. So I challenge you when you do your homework to see if you can make your answer look like what the ebook says. Okay? Because that is a really big skill that's going to come back. We just don't have time, every problem we do today, to simplify it, simplify it, simplify it. All right? All right, there's your derivative. All right? Let's do another one. What if we write, if f of x equals, how about tangent x sine x? I want us to find f prime. All right, Melanie, where's Melanie? No? Hector. Hey Hector, you doing all right?
Yes, sir.
Okay. Hector, so my first question is, do you see a product in here? Do you see multiplication? Where?
Tangent of x is being multiplied by sine.
Okay, so it's between these two, right here.
Yeah.
Right? And that's the only multiplication, right, Hector?
Yes.
This x lives inside the tangent, it's the argument, and that lives in there, that's the argument as well, right? So there's only one product there. So now, Hector, let's label each of these, right? F and G. And then we're just going to follow that formula, right, Hector?
Yeah.
Okay, so Hector, give me the first piece of this.
It would be
Or tell me what you're going to do, however you want to do it.
prime of 10.
Okay, you're going to take the prime or the derivative of tan x. Okay, keep going.
Sine of x
Times sine of x
plus
plus
sine of x prime
sine of x prime.
times tangent of x.
There we go. Thumbs up or down for Hector? Thumbs up. Okay, good. Now, you have your formula sheets if you don't remember. Let's see. Farah, you're up. Doing all right today? Yeah? You okay? Today feels off. I don't know what's going on. Y'all all right?
So it's a secant, square secant x.
Yeah, okay, so look at your formulas, or this is one of the ones that I said you need to at some point. The three you need to try and remember. Derivative of sine, cosine, and tangent. But look in your reference sheet. We say that secant squared x. Secant squared x. That's the derivative of tangent x. All right, and then we'll just keep going. Times sine x plus, I want to get, oh, you go ahead. Yeah, cosine x, derivative of sine x is cosine x. times tan x. Okay, now this could probably be cleaned up. Like, what is tangent by definition? Sine over cosine. And so do you see one of the cosines would cancel? So there's things that we could do, but just all we want to do right here today is make sure we know how to take a derivative using the product rule, right? How does this seem to you? Seem okay? All right, do another one. How about if I say y equals square root of x minus x plus 1 times x to the fourth minus 3x plus 4. I should mention here that if you wanted to, before you even start doing any derivatives, you could multiply these and do like, not FOIL, because it's a bunch of, it's not 2 and 2, it's 3 things and 3 things. You could expand this out and remove the parentheses. And if you did that, you wouldn't have to use any product rule because you could just do them one by one. You'll get what I'm saying? If you did the multiplication through, you would get a total of 9 terms, and then you could differentiate each one by one and totally go around the product rule and not need to use it. But it's probably not worth your time to do that because the product rule should be faster. All right, everyone see the product? Right there? So this is our f, that's our g. And so now we just play this game again. Here's f, here's g. So I'm going to take the derivative of the first one times the second one plus the derivative of the second one times the first one. All right, that's the formula. So who's on this hot spot now? Lewis? 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 Oh, there you are. Okay. All right, Lewis, you feeling all right? How do you feel about the derivative of this first one here? Can you do, how would you do this, Lewis? Pardon me? Well, yes, I want you to say the answer, but let me ask you, Lewis, can you just do the derivative of each one of those separately? Yes, because? Pluses and minuses between them, right? So we can just do them one at a time. Okay, do you feel comfortable with the derivative of that? Perfect. Okay, everyone, see how Lewis just spewed that out real quick? Derivative, that's that. Everyone should be at that point. Like, that's the one I told you you need to remember, right? It comes up a lot. Derivative square root of x is 1 over 2 root x. Good. You want to keep going? Minus 1? And then plus nothing, right? Plus 0 because derivative of a constant is 0. So that's it. We're done there, right? Close the parentheses. And then this one, don't take the derivative, right? You're just going to write it out. Plus, all right, the next one is Emily. Emily? 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 There you are. Emily, are you following okay? Yes? You're okay? All right, how do you feel about the derivative of this one? Okay? You want to go for it? Okay. What do you got for this one? 4 comes out. X to what power? 3. Good. Okay, what about this next one? Minus 3. Very good. Yep. Because the constant comes for the ride, and the derivative of x is 1. One more. 0. Good. There we go. There's your derivative. And then just write the second function, and we're done. At least we're done with the calculus part, right? All right. Are we feeling all right about this? Yeah?
So apparently for a test, you don't want us to multiply all of those together, like actually.
Yeah.
Once we get there, you're okay.
I call this the raw derivative. okay, because it is the raw form of the derivative. Right after you differentiate, that's what it looks like. On the test, I will ask you for the raw derivative, and that allows me to ask you more questions, so you don't have to sit there and simplify each one, because then that would take you more time. So I'll say, you know, find the raw derivatives, and I'll just give you a bunch of problems to do. Okay? All right, let's proceed. I'm going to see if I can't throw a curveball at you here. What did I tell you about these rules? I said to you, we don't have to use the limit anymore, but what's the catch? What's that? They're going to get, the functions are going to become more challenging, all right? So everything I've given you so far, I think, has been pretty straightforward, right? Let's see what this, see about this. How about x to the third plus 1 times x squared plus x minus 4 times sine x. Ooh. Okay. Alan? Where's Alan? Alan, are you following okay today?
Yeah.
Okay. Alan, what is the big issue with this one? Do you see what's different here?
Yeah, there's
Three things being multiplied. Three what we would call factors, right? Anytime you have things being multiplied, each one of them is called a factor. So you have three things being multiplied. That means you have two products, right? Right there and right there. You have two multiplications. Have I given you a rule, Alan, for doing three things? No, only two, right? Only two. So here's the way we're going to proceed through this. We have some options, but here's the option I'm going to do. I'm going to look at my multiplication. I'm either going to look at this one or this one. It's my choice. I'm going to go at this one, and I'm going to say, there's my multiplication, all right? Alan, if I do that, are you okay if I call this whole thing over here F, and then call this right here G? You follow that, Alan?
Yeah.
Okay. Everyone see that? So Alan, following that, and following the product rule, if all of this is F and that's G, Alan, tell me what I would write down in the next line. So the derivative of this would be, first thing we have to do, Alan, right, is this, take derivative of F. And let's do it where we do it with the prime, right? Okay, so what would I write?
X cubed plus
Okay, put that in parentheses, right? And then,
x squared plus x plus 4.
and what do I want to do with this? Derivative. So I'm going to take that whole thing and take its derivative. Does everyone see that's the very first part of this? Right? We haven't taken the derivative, have we? We've just written it down. What we need to do. You want to keep going, Alan?
Yeah.
Times what?
Sine x.
Sine of x. Very good. Alan, you're doing great. I'm going to give you the option to keep going, or I can move on. Keep going? Okay. Plus, right? That's the formula. All right. Now what am I going to write, Alan?
Derivative of sine x.
Okay. Derivative of sine x.